Yes friends, I'm Professor Kumar and you are learning at the Galaxy Online Learning, the venture of Galaxy Tutorials. Today we are seeing 10th standard Maths Chapter 6 Triangles. Okay, and I will be going through the details in these. First, fill in the blanks. All circles are or small, big or similar. If they are of the same radius, then only they are congruent. They have not given us. Second, all squares are again similar because the sides may be of different length. All equilateral triangles are similar. Otherwise, equilateral is not similar to isosceles, is not similar to scaly. Okay? Okay, and isosceles also the base may be small, big. So only equilateral triangles are similar. Two polygons of the same number of sides, so either they are triangle, they are square, same sides are similar if their corresponding angles are equal and the corresponding sides are in proportion. Okay, so corresponding angles are equal. So 30, 30 and 2 then 4, 3 then 6. So the proportion is same. So that is how we study the similarities. Give two different examples of similar figures. Take any two 20 rupee notes. They are not same. The numbers are not same. They are two different notes. They are similar. Non-similar figures. Two rupee coins you take with different shapes, etc. They will not be similar. Okay? They will. Or some may look old, some may look new, shiny. You will never find them to be same. So my friends, are they similar or not? We have to see. Remember two rules. Corresponding angles are equal. Corresponding sides are in proportion. Corresponding angles are not equal. There is no 90 here. Don't look at the story. They are not similar. Okay, let's look at exercise 6.2. In the figure given in the textbook, okay, DE is parallel to BC and I am supposed to find EC. I am supposed to find EC. Okay, number one, AD is AD upon DB. Remember friends, in a triangle, if one side is parallel, okay, then 1 upon 2 is equal to 3 upon 4. Okay, so by that method, I get EC is 2. So simple, my friends. Look here also, twisted, same thing. Okay, 1 upon 2 is equal to 3. 1 upon 2 is equal to 3 upon 4. As simple as that. Okay, nothing great. Learn by technique, shortcut. Again we have come here. 1 upon 2 is equal to 3 upon 4. Only if they are parallel to the base. Okay, and they have given us their parallel. Very nice of them. So I have done all the sums for you. Okay, if they ask you to find full, of course you have to add the 2. If full is given and you have one part, then you minus that and you will get, that is algebra, my friends. Nothing to do with geometry. And they have asked us, state whether it is parallel or not. For it to be parallel, if 1 upon 2 is equal to 3 upon 4, they are parallel. If 1 upon 2 is not equal, they are not parallel. As simple as that, my friend. So basically you are supposed to find the ratio of 1 upon 2 and 3 upon 4. Or in simple language, PE upon EQ, PF upon FR. Nothing else you are supposed to be doing. Okay, and the sums are just 1 mark in the exam. So don't waste your life on them. In this figure, LN is parallels. These are parallels. Okay, that we are given. So see them as separate triangles. Okay, and prove that AM upon MB is equal to AN. We are supposed to prove 1 upon 2 is equal to 3 upon 4. Friends, Very difficult? No, very simple. Take one triangle at one time. So I have A, N, D, A, L, C. Separate the two triangles. So I have 1 upon 2 is equal to A upon B. Take the second triangle, my friends. A, L, C. AC is common to both. A, M, B. Okay. A upon B is equal to 3 upon 4. So 1 upon 2 is equal to A upon B. A upon B is equal to 3 upon 4. So my friend, 1 upon 2 is equal to 3 upon 4. So simple to remember. Instead of 1, write AN. Instead of 2, write ND. First learn it like this. If this idea will come to you, then you can do the sum fast. Don't try other shortcuts. These are the simplest way. Let me look at the sum number 4 also like this. These techniques are very important to save time in the exam. Learn to read diagrams. DE is parallel to AC, my friends. And DF is parallel to AE, my friends. Okay? And we have to prove BF upon FE is equal to BE. BE is here, my friend, 3 upon FE, that is 4. Okay? So 1, 2 is equal to 3 upon 4. I think it is very apparent to you, my friends, if you look at it also, that this is quite simple. Okay? But we will do it this time. First, take big triangle ABC and take one set of parallel line only. That is DE is parallel to AC. First thing. Now, we will get BD upon DA is equal to BE upon EC. 1 upon 2 is equal to 3 upon 4. First triangle. Separate the triangles. So first, take the triangle, my friends, BCA, and with this, we take DE parallel to this. First step. Okay? Second, take the same triangle now. Okay, here you will get your 1, 2, 3, 4. And take the second triangle. And now you will take the other parallel line for that purpose. So I have in triangle ABC, DF is parallel to AE. Is parallel to AE. So this one portion I don't want. Okay. Now I will get, and this is of course B, I will get A upon B is equal to C upon D by the same method. And then, my friends, I will combine both the equation and my answer will come. Because triangle is same. Triangle is same ABC, so we are not bothered. Okay? So this is how we will do the sum in this case. So basic proportionality theorem we have to start learning to use. In this we are having DE is parallel. This is same like this. Okay? Only thing we have made it 3D so that it looks difficult for you. Okay? So take triangle 1. DE is parallel to OQ. So take triangle first, which is given DE P O Q. First take this triangle, my friends. Then, my friends, in the same triangle we are seeing, we will get two different type of ratio. Okay, first we are having PD upon DO. PD upon DO is equal to PE upon EQ. Then, my friends, PD upon DO is equal to, now take the second triangle from here, PDO and F and a D. So, take the second triangle, my friend. Yes. So take triangle 1, take triangle 2 first. Okay? And you will get. And when you compare because they are same triangle, PQO, you will get the same answer. Same type of sum, only diagram different. They use this diagram in this and made it 3D. Basic proportionality theorem, basic proportionality, basic. But if I have to show they are parallel, I have to use converse of basic. Ratios equal, therefore lines are parallel. Don't forget converse. Remember Pythagoras, remember basic proportionality theorem, remember converse of basic proportionality theorem, okay, Apollonius theorem. If you don't know the basic theorem from 9th standard, I'm sorry for you, my friends. These are very simple. And these sums are just 2 and 3 marks each. Again, we see the diagram. They look very complicated, but they're very simple. Take one triangle at one time. You see parallel lines. Okay? Don't see all at one time. That's what is the problem. In triangle OPQ, take this triangle 1 and use basic proportionality theorem. OPR, use basic proportionality theorem. Take both the equations and answers there. This is the 4th sum we are doing. And if the lines have to be proved parallel, you will use the converse. Okay? Look here also, my friends. What is great in this also? Prove that a line drawn. Basically, you have proved it in class 9. This is BPT. This is BPT. Please learn it. 9th standard. See, again we asked in the 10th standard. So kindly prepare. Okay, we are saying AD upon BD is 1 because this is the midpoints. Okay, midpoints, mid. Okay, and DE is parallel to BC. Ratios are equal, therefore this also has to be equal. 1 upon 2 is equal to 3 upon 4. So 1 is equal to 1. Therefore, it has to be the midpoint only. Okay, 9th standard. They have specially written in your book. You can read. Kindly look at 9th. You have a lot of time now on your hands. Let's see. Now use converse. Remember, you have done it in the 9th standard. See, it's written in your textbook. Okay? We have to prove again. So please study basic proportionality theorem. Converse may come also in the 10th standard because it is expected. No problems. We will again prove ratio 1 and 1, 1 and 1, they are equal. Therefore, this is parallel to this. Converse of BPT. Okay? Remember, such sums don't get more than 1 or 2 marks. Huh? So don't feel very happy. This will help you to reach above 90. But till reach 90, you must know all harder sums. ABCD is a trapezium. AB is parallel to DC. Two sides have to be parallel, otherwise it is not a trapezium. Okay? Diagonals intersect at O. We have to prove AO upon BO is equal to CO upon DO. Okay? We have to prove these ratios. So first, we draw construction OE parallel to DC. Okay, number 1. Then in triangle ADC, this triangle I have. Look at this triangle, my friends, only. In this triangle I have 1 upon 2 is equal to 3 upon 4 because EO is parallel to DC. Perfect. Then I will go ahead and I will see by using BPT, I will get DE upon EA is equal to DO upon B. See the triangle I am taking, my friends. The whole trick is in taking the triangle. Okay, and when I combine them, I can do that. So simple it was. So first I took the straight triangle, then I took the inverted triangle. I never went to the other side at all. I need not go because 2 marks, sums don't require you to take 3 sides. Learn your theory well. It will come 15 times. Don't get bored. Diagonals intersect each other. We have already done this sum. This is the converse of that same sum. We have to prove it is trapezium. So I have to prove that these are parallel. Okay? To prove them they are parallel, I have to prove that the sides are in proportion. So I will prove AE upon ED is equal to A upon OC. Same like last time, same to same. I have to prove same. Okay, and I will prove that also similarly it is a trapezium. So let us have a look at exercise 6. So exercise 6.2 was a basic proportionality theorem, all the sums and converse. Let us look at 6.3. This is on similarity, test of similarity. You know, my friends, that SSS test, when three sides are in proportion, triangles are similar. We have AA test, my friends. If two angles are equal, automatically the third will be equal, because all three angles are 180 degrees in a triangle. Okay, and I have ASA. Okay, or SAS, side angle side. Never have ASS. You will be an ass if you use like that. Be very careful. So let us have a look. Which are similar? You see, AAA similar. Look here. See, 2 upon 6. When you try to find like this, you will say, be careful. 3 ka 6, 2 ka 4, 2.5 ka 5 are doubles. It is similar. You have to learn to twist the triangle. Use your brain. Don't direct 2, 6, 3, 5. Don't be a fool. First look at the diagram. You will rotate the diagram. Here I find, my friends, no angle, no side matches. 3, 6 double, 2 ka 4 is here, but 2.7 is not 5. Sorry, so this is not similar. They trapped you till the third one. 1 mark sums. Here I find angle is 70-70 and those sides which contain SAS. Okay, my friend, SAS. Don't be an ass. You will get 0 marks. The angle has to be between the two sides. Then only you can use SAS. So when I have 70, I have to use 2.5 and 5 ka 10 and I have to check that way. Okay? So don't try anything else. Then let's have a look here. Here I have 80-80. So I will have these two sides, I'll have these two sides. I can't use any other side. Now the ratio is not equal and I will say, okay, this is not similar. When I come here, my friends, I have 80-80, 70 and 30. Now, when I add these two, I get 150, so this has to be 30. So nice of us to find out that. And 110, 80, so this has to be 70, my friend. Now you see how to do? They may not look nice to you, but they are similar. A, test of similarity. Okay? Simple. I'm just revising your 8th and 9th. I have not reached 10th, I think, till now. Again, your alternate angles and corresponding angles from your 8th standard. See, what are we doing in 10th standard? Triangle ODC is OBA. Okay? DOB is a straight line. Okay, therefore, angle DOC, okay, plus angle COB, this is a linear pair. CDOB. Okay, my friends? So this has to be linear pair. You can't get 180 degrees, I can see. Okay? So when I substitute the given angles in it, I will get all the remaining angles. Corresponding angles are similar, or in similar triangles. That is the thing. So first I must get complementary angle. Second, corresponding angle. Corresponding angles are equal. Don't forget in similar triangles. We saw the two conditions required. Okay, that is why. Okay, I can find all the angles. Here, diagonals are intersecting. It is a trapezium, and they have told us AB is parallel to CD. Okay, and we must show AO upon OC is equal to OB upon OD. This is what I have to show. So again, we have to say alternate angles, vertically alternate angles, vertically opposite angles, my friend. Triangles are similar. Therefore, corresponding sides are in proportion. 8th standard, my friend. Okay, nothing new brought in here. If you find this difficult, I'm sorry, that means you have not studied your 8th standard. Because it has not yet begun. You wait till you see the sums. There are 6 exercises. Just wait. Now, again, diagram looks huge, horrible, but very simple. Okay. In the triangle, I have to show 2 triangles are similar. You can see ratios are equal and therefore angle is common angle is also there. SAS test of similarity. And in this, I have 2 triangles. I have equal and common angle R. That is why AA. Remember, third is not required. It is not compulsory because of 3 are 180 degrees. If 2 are equal, third has to be equal. Third one, in this case, I have to show the small triangle is similar to big triangle. I have to show small triangle is similar to the big triangle. It is what they have asked me. So first, corresponding sides are in proportion because they have given congruent triangles. And here also, and here I have the ratio by dividing them. AD upon AB divide, I will get equal. Angle A is common, so I will use SAS test. Same like this. Does the diagram look there? They did draw one line for you, so you are looking at differently. If I drew this, what diagram would have been same? You can have a look, my friends. So this is how they confuse you. Rotate the diagram, rub out one side. Oh, sums are difficult. Okay, sums are not difficult. You must stick to your principles. If your theory is correct, nothing will go wrong. All are just 2 marks. Keep practicing. Here, altitudes intersect in P. We can see that. Show that triangle AEP is similar to triangle CDP. So first is similar to second. And second, ABD. ABD. The third one is similar to CBE. CBE. See how they are manipulating us. So we will first separate the diagram so that we can understand. In this, I have AEP. 90 is given. EAP. And CDP. CDP. Okay, my friend. Now any blind can see 90 vertically opposite angle. So this is nothing great. So when you separate the diagram, it takes half a second. Okay, let's see this one. ABD. Okay, I have ABD. And I have CBE. I have CBE. Remind you, my friend, of something. Common angle is B. You see? And then can you see vertically opposite angle, etc.? Extremely simple. Plus. Fool people, 90 given. Common angle. What more do you want? So if you don't separate the diagram, I don't have pity for you. First, separate the diagram. See the third one. In the third one, I am having AEP. Similar to this. AEP. AEP. This being a right angle. And ADB. ADB. This is also the right angle. See, my friends? 90 is given and angle A is common. So it makes our life pretty easy. Look at this, my friend. PDC, which we already used on top. PDC with BEC with BEC. PDC. Sorry. P, D, and And now I need BEC. So B will be down and E will be the perpendicular which is coming. This is the diagram, my friends. See? So in this case also I am finding 90 angle is already given, both sides, and common angle is there. So all four, my friends, what they twisted you. Of course they won't ask 4. They'll ask only 2 in the exam for 2 marks. 90 degrees and common. Nothing else was required. Therefore, a test of similarity. Bas. Nothing else is required in sum number 7. And all 4 will never come. 1 mark 1 will come, 2 mark 2 will come. Nothing more than that. Don't expect otherwise I'll give you 4 diagram and give you 4 marks like that. Okay? E is a point on AD, okay, of parallelogram ABCD. ABCD is a parallelogram, so these sides are parallel, my friend. That is what we know. Very nice. And we have to show triangle ABE. I have to show triangle ABE. ABE, okay, is similar to triangle CFB. CFB. Okay, B is here, C is here, CFB. I will show these two, my friends. Okay, first locate the triangles. Now, my friend, you can see in the diagram, these are opposite. A and C are opposite angles of a parallelogram, which are congruent. And you know the Z. So I get alternate interior angle because these lines are parallel. Okay, therefore, I don't need to see anything else. I will use the angle test for similarity. Learn to separate the triangle. Once you separate, life becomes easy. Okay, let's see the next one. Take a notebook, draw the diagram and write how I write first. It's easy to understand. I have to see ABC and AMP. So I have been given 2 triangles, ABC with right angle and AMP right angle. Okay. Again, my friends, we just did that sum. Does not remind you? We just did. See? Same nonsense, but the diagram has been turned. How they keep troubling you. You are the same we just did. 2, 3 sums mark. Okay? So common angle is A and 90 is there. Therefore, a test of similarity. Now, because triangles are similar, sides are in proportion. 1/2 is as simple as that. Okay? So learn to see. Don't get confused. And don't get tired. Do 3 sums, do 5 sums. Relax. Get them perfect. CD and GH, which you can see, are bisector. This is based on angle bisector theorem. Okay, so we will use like that. Are bisected. So we have to prove triangles are similar. They have given triangle ABC is similar to triangles are similar. We have to prove sides are in proportion. First, angle bisector, angles are equal. 2 times we have used here and there. Okay. And then already angle A and F are equal because triangles are similar, angles are equal. Okay, that's why by a test, sides are in proportion if triangles are similar. I remind you once again, my friend, first corresponding angles you locate. Okay, second bisected angles you locate. These are all congruent because triangles are given similar. Therefore, a test. Triangles are similar. Therefore, side 1 upon side 2 is equal to the sides of the other triangle. Don't forget the method, my friends. So, C is equal to G, B is equal to E, A is equal to that. If triangle is similar, corresponding angles are. We're trying to put it to you, okay? And sides are in proportion. So, AB upon FE will be equal to AC upon FG. They are not equal, similar, they are not congruent. They are in proportion. Angles are equal. Okay, so this was the trick in that. And then we already proved, so we take the other side, already proved, we use one more property. So we are just using the property 3 times. That's why I tell you, friend, all 3 will not come like this. Don't be a fool. Of course, you should practice. Only one part will come in the exam for 2 months. But the paper has so much variety, but people get tested and they feel this is a brand new sum. Okay? If it is shortened, what is your problem? Now, E is extended. Okay? Isosceles triangle ABC. So AB is equal to AC. Okay, perfect. And I have a perpendicular. I have a perpendicular. I have to prove triangle ABD. I have to prove this triangle half is similar to this triangle half. Okay, I have to prove this one. Yes. Okay, I don't need technically the top portion. And these are right angles. Again, how difficult it looks. Rotate. Rotate. Bring C on top. And blind people have a look. Okay. Blind people start looking at diagrams carefully. 6th time we are doing this. How nice it looks. Let's rotate. Learn to see the diagram. So 6th new theory won't come 6th new theory. Okay? You should know why. So again, learn to see how I tell you. Because till yesterday you were memorizing maths. You cannot memorize maths like that. It can only come with practice. Look at sum number 12, my friends. Sides and medians are proportional. Very nice. Show that triangles are similar. Idiotic. Median means divide into 2 equal parts. If sides are equal, half sides are also equal. Okay? So this is what we have done. Now midpoint. Midpoint. Okay? SSS. If sides are congruent, half sides are also congruent. So 3 sides are given and half of also are given. So I am using SSS test. If SSS is congruent, and that I might tell you, my friend, corresponding angles are also equal. They are not in proportion, they are equal. Small triangle, big triangle. In these 2 triangles, proportionate, angle equal. So SAS. When you have a ratio SAS, this is how you have to see the similarity. Okay, let's look at the lower sum. D is a point such that angle ADC is equal to BAC. AD. So this is given to be equal, and they have drawn it also as 90. Very nice of them. And we have to show CA square is equal to CB into CD. Now look so difficult, my friends. Learn to break this. So this will be CA into CA is CB into CD. What is square, my friends? When you multiply the same thing by itself, it is a square. Now bring this guy down. CA upon CB and take this guy there is CD upon CA. Okay, interchange. Bring the numerator down, the denominator on the other side. This is what you have to prove, my friends. And to prove this, which triangle will I take? You can see there, I get, see the common letters, I get A, B, C, D. I require only this. So I require triangle ADC and BAC. Your A is common, my friends. Learn to read. It's so simple. But if you can't think like this and you want to think like this, you can take the whole day. You are welcome, my friends, to waste your time. So this was the trick in this. You can get squares in similarity. So square means multiply by itself. I do not have multiplication. I have proportion. Sides are in proportion. Make the sides in proportion. And we have solved your sum, my friends. And You just go reverse. You learn to write like this. So this was a trick in the sum, my friends. So it's not so bad. Array, nothing array. First identify the what you require. See which triangle. Just prove them similar because side is in proportion. Side in proportion can only be in similar triangles. There is no other theorem for that. There is not BPT. There is not converse of BPT. So this is the tricks, my friend, you should understand. When you see the sum, you should feel comfortable. Okay? I forgot, I tried, I got stuck. These are typical example of laziness and lack of practice. Side AB and AC and median AD. Again, same nonsense has come. Two sides and median are proportion to. Same language. Show that ABC is similar to PQ. First, my construction will make that little corners for both the sides. Okay? So, we have made construction. Then, we have made that, in this case, PM is equal to M. We must make construction like that, otherwise we will not be able to prove similarity. So D and M become the midpoint and they become the median. So simple as that. Okay? First median was this. Now my median has become this. I change the median. So that is how I will get the sides are in proportion, equal, because median all is divided into equal part. And I will, because angle is same, I will use SAS test. A, B, D and C, D, E. Okay, so that's how my trick is. That, oh my friend, these two angles just. So learn the trick. Also, now, PM, after this we will move here. Okay, and same we will use and we will prove. SAS, two times we will use. Vertically opposite, vertically opposite. Same to same, two different triangles. We will not touch the two. Okay. Now, AB upon PQ is equal to AC upon PR. Written, my friends. Can read. Okay. And equal to the median. Okay. Using that, I will prove triangle. This, forget the left, the right triangle is similar to the right triangle. Right hand sides are similar. Now, because right hand sides are similar, therefore, corresponding angles are congruent. 2 is equal to 4. I will get 2 is equal to 4. Similarly, when I see this type of triangle, I will get 1 equal to 3. We don't have to do it two times. We never do 2 times. Similarly, so once I have proved that the angles are equal, I will add the angles and get my answer. The trick, again I remind you, my friend, first construction, they had told us sides and median are in proportion. Construct and join. Okay, and use this as the median now. Correct, my friends? And then, as you have seen, triangle ABD is similar to CDE. So I will remove this. I will get these two triangles as similar. Then you flip to the other side. Okay? Simple. So go to that PQRN. So instead of AB, it will become PQMRN. Nothing else changes. Same to same you copy. Absolutely. And then you will say, because triangles are similar, 2 is equal to 4. And again, we won't say similarly, 1 is equal to 3. Then you add them together and your job is done. Okay? Learn the method. Of course, it will require practice. This is exercise 6.4. Earlier, as you saw, was based on similarities. Now, this, when we have come, is areas of similar triangle. Now, areas of similar triangle are in proportion to side square. If triangle 1 is similar to triangle 2, then area of triangle 1 upon area of triangle 2 is proportion to side 1 of side 1 square. Corresponding right. One I write small and one I write big. So that you understand. So this is the theorem, my friend. In 8th standard, again open your books. If you don't believe me, read it and you have to solution. And such a nice, but they'll give you 1 marks for that. Because you should know similarity ka theorem. As simple. And of course you can remove square roots and all, which I can't help you much. Now I have a trapezium A, B, C, D, and these two are parallel. And diagonals intersecting O. Remember we did the same sum. Okay. Now angle 1 is congruent to 2 alternate angle, 3 is congruent to 4 alternate angle, 5 is congruent to 6 vertically opposite angle. Triangles are similar. Areas of similar triangle are in proportion to side square. But they told us, learn to read. They told us AB is to CD. So, blind people, हजार time I keep telling you, change the side. So, if I square this, I will square this. And that's how I get my answer. As simple as that. Okay? Sides are in proportion. They've given you a value. So nice of them. Areas are proportion to the side square. Side of one triangle upon corresponding side of the other triangle square. This is what I did. Instead of sides, I have a ratio. I have a direct ratio. I don't need the measurement. This was the trick in this sum. And it looks nice. 2 marks. So don't start jumping. None of these are 4-5 marks. Now, in this figure, altitudes AP and DM are given. Of course, diagonals intersect in O. And same base BC. So I have a triangle 1, I have a triangle 1, and I have a triangle 2. BC is common to them. Okay? Now, area is half base into height. Base into height. Half cancel. Okay, and base is common, cancel. So AP upon DM. That is how to do, my friends. Now, 90-90 you already know. Plus vertically opposite angles you can see. Okay, therefore 2 angles are equal, triangles are similar, and therefore areas are in proportion. Okay, this is how to do the sum, my friend. Okay, I remind you once again, area is half base into height. Okay, remove the half, remove the base, height 1 upon height 2 will remain. Second, in the triangle, they are similar because of A test, 90 and vertically opposite. Third, ratio is equal. Okay, let us look at the fourth sum. In the fourth sum, areas of 2 similar triangles are similar, areas are equal. 2 things are given. Prove they are common. What nonsense, my friends. We have to prove them because ratio will come 1, 1. 1 means equal. So on squaring, all will be equal to each other. Remove the square root, all will be equal. So by SSS test, because the sides are equal, I will have triangles are congruent. Okay, see my friends how 2 marks come. So don't make your life difficult. Now this sum is 4 marks. So that is why I presented in a particular manner. Have a look how to study the parts. Okay, part 1, part 2, part 3, part 4. Learn to handle one by one. We have 10 sums which are typical for 4 and 5 marks. You have to be careful. They will require you to practice 4 to 5 times. There is no shortcut. So this is how I explain. D, E, F are the midpoints. Find the ratio of triangle D, E, F to the big triangle. Small triangle is to the big triangle I have to plot. Okay. First, I will use B, D, E, F is a parallelogram. First point, I must prove B, D, E, F is a parallelogram. Why? Because opposite sides are equal and parallel. Very nice. Second, I will go for the triangle. Triangle 1 and triangle 2 of the same parallelogram. Okay, so I will prove them that they are congruent. Then I will go for the other, I will go for 3 and 2. So 1 and 2 triangle, okay, and 2 and 3 triangle. This is how we go, my friends. Okay, same method. Always all are same. Then, and you can kindly see also, all are using SSS. There is no garbage. Then areas are equal. Okay, how do I get the area equal? If triangles are congruent, the areas are equal. Then I add the areas, and I solve to get ratio 1:4. That is 1/4. 1, 2, 3, 4, and this is only 1. So 1/4. So remember, my friends, triangle 1 and 2, triangle 2 and 3, areas are equal. Add the areas. 1 plus 2 plus 3 plus 4, and 1 is only 4. So 1:4 you will get. So don't have to feel very hard. It's extremely simple, my friends. What steps are there? You must learn to write and present it. You try any other stunts, you will end up with no marks. Here I have to prove ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. I have to go for the medians, my friend. Okay. So A, B, C, D, E, F are similar to similar triangles. Areas are in proportion to side square. So I square any side and I will have side square. Okay. I remind you once again, my friends, area 1 upon area 2 is side 1 square upon side 1 square, corresponding sides. Okay? If triangle 1 is similar to triangle 2, if. Otherwise, if I don't know areas of triangle 1 and triangle 2, area 1 upon area 2 is half base into height upon half base into height. Simple. There are only two ways, and I've used both the methods here. Triangle the same, proportion the same. So simple. And angle is given. So, areas of two similar triangles are proportional to the square of the corresponding side. Therefore, if you say this, I can say it for other side also. Why not? They didn't say which side. Corresponding sides. That area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. Now this is the square, this is the equilateral triangle, okay, is equal to half the area of the equilateral triangle made by the diagonal. So this is triangle 1 and 2, this is double. That is what I have to prove. First, both are equilateral, my friends. Therefore, areas are proportional to side square. How do I get the side for an equilateral triangle? Root 2 times, because diagonal is root 2 side. Diagonal is root 2 side. Okay? If the side is x, diagonal is root 2x. Okay, so as simple. Now he has used BC. Okay, instead of the all sides square, all sides are equal. So this is also x, my friend. This is also x, my friends. Okay, so that was the trick. So when I divide, I get 2, or this is half. If that is 2, this is 1, that is half of it. So the trick again, I remind you, my friends. First two equilateral triangles are similar if they are of different sizes. Number 2, areas of similar triangles are proportional to the side square. Number 3, side use the diagonal side and any one side of the square, whichever you want to use. So you will get cancellation and 2. This is what you want. If one side is 2, the other side is 1, automatically that is half of the bigger side. Now, if this multiple choice 1 mark question, you don't have to do working, but I'm explaining it to you. Okay, we have to prove the ratio of the triangles. Now 60, 60, 60 means they are similar. Okay, areas are proportional to side square. This upon this, this upon this. Okay, now my friends, as you can see there, let each side of the triangle be 2a. Okay, so you will get 2a upon a. Okay, because D is a midpoint. Read this very carefully. So this is a, and this is 2a. So that's why I get the answer 4:1, because I will square the side. So I will get not half, I will get 1:4 or 4:1. Whatever. The bigger will be 4 and the smaller will be 1. Here I have ratio 4:9. Okay. So what will be the area? So square the thing. I get 16:81. Don't have to break your brain. Area of two similar triangles is proportional to the square of their sides. Let us look at exercise 6.5. Okay, my friends. Sides of triangle are given, and we have to say whether they are right angle, and if they are right angle, we must find the hypotenuse. For all the sum, I am giving you common method. Number 1, take the largest side, square it. Take other two sides, square it. Now, the biggest side square should be equal to the sum of the small side ka square. Sum. Then it is third, 4, it is right angle triangle. Because it satisfies Pythagoras condition. All the 4. If it is not equal, it is not right angle. Don't have to break my head and your head. Take the biggest side, square it. That will be a left hand side. Take the other two sides, square it and add them. Are the two equal? Yes, it is right angle. No, it is not right angle. Because it does not satisfy or does satisfy Pythagoras theorem. That is not the sense. Okay? Now we are not going to make them squares, add 4 times, 8 times. I am not going to waste my time. You should learn Pythagoras from 8 side. But I showed you a shortcut. Here, I have a perpendicular, PM is perpendicular, and of course that also is 90. I will show PM. I just taught you that, my friends, my trick. Okay? But here, you will use Pythagoras theorem. Simpler. You can also use PM into PM is equal to use two similar triangles, but this is much easier by Pythagoras theorem. Pythagoras theorem, you have to use two triangles. First, you take triangle PQR and do Pythagoras on this. QR is a hypotenuse, my friend. And you take any one triangle, PQM. This is right. Do Pythagoras on it, my friend. And when you add them, you will get an answer. Change the sides, of course, add them. This is algebra, nothing to do with geometry. So, take two triangles. See, I draw the separate triangle. We triangle today. Of course, you can take PMR also. But we don't require 3. When we take 2, we can find the answer. Simple. Okay? Please check. These are just sums. This plus this will give you this. Okay? Nothing. I have not twisted or changed anything. Plain algebra, betweenness. The idea was to use 2 Pythagoras. Practice. Difficulties that come back to us. That's why I made it into steps. Again, same nonsense. A is right angle, C is right angle. They keep on troubling us like mad. Okay, all these three sums, okay, I will use similarity and I will get, okay, of the two triangles I will get, so first two triangles are similar. Second, sides, how they are similar? A plus. We don't write 3, yeah, because there's no meaning. Sides are in proportion. Now which side to take? Don't be blind. AB upon is equal to AB into AB is equal to BC into BD. Okay, so AB upon BC is equal to BD upon AB. Learn to write reverse for all. I taught you this trick, my friends. That's how we get squares. Otherwise you can't get square. So I have to take a triangle such that I have A common between the two, and I need BD. Now my friends, if you are blind, okay, ADB, CAB. So I've used B, I've used C, I've used D, I've used A. As simple as that. Which triangle? Right? Triangle is in front of you. All 8th standard Pythagoras. Now, isosceles triangle. And I have to prove same nonsense. Same. Use Pythagoras and do. Only once Pythagoras is required. And in isosceles, two sides are equal. So you can add them together. Okay? So, just to make the logic clear to you, C square is A square plus B square Pythagoras theorem. A and B are equal. So it becomes 2A square. This is what he asked you to do, my friend. So don't think, these are not sums. 1 mark. Again isosceles, again C. But I will prove this is the right angle. So I will do the converse. As simple as that. Two sides are equal. And when I add the side, I get equal. Okay, so by Pythagoras, it is the right angle, friend. So nothing changed. Either this or either this. 1 mark between. Come. Sums are similar. Here, now I get 2. So it looks an equilateral. 2A. I have already done 2A ka sum, my friends. I have already done 2A ka sums. 2A, A. 2A, A. Why? A plus A is 2A. We have already done. Because equilateral altitude is the median. That is the property of equilateral triangle. Pythagoras is sum of two side squares is equal to hypotenuse square. So I will get like this from this, that AD is root 3A, because I cannot remove square root of 3. Okay? So don't have to look confused. That means you didn't do your lower classes at all. I will show you some that belong to 10th standard. Don't worry. Let's have a look now. Square of the sides of the rhombus is equal to sum of the squares of its diagonals. Okay? So simple. So I have to prepare AB square, BC square, CD square, DA square is equal to AC square plus BD square. No problem, my friend. I must see carefully. I must take triangles in this manner. Okay, these are my diagonals. We have done a sum like that before also. Take triangles like this. That will make your life easier. Okay, so you can use Pythagoras theorem. This is O, this is A, this is B, C, D. Okay, so this is a hypotenuse. If you can't see, I will write for you. Okay, and the squares. Add the two, and your answer will be 2. As simple as that. Okay, so these are the sides, and these are the diagonal pieces. When you add them, okay, look here. Diagram should draw like this, not like this. You'll never get answer like this because they made it very funny, big, small, square, but looks like this. Okay. Now how we know? Because when you draw by reading, you will see what we have drawn is quite correct. Okay, but shapes don't matter. First, we will join all. So whatever is half, I will join. Okay. Whatever is half, I will join. This is what we have done. Now there are twists. That's why they put a square and everybody is confused. Okay, so join everything. And see my triangle AOF. Okay, and triangle BOD. Okay, and my triangle BOD. Okay, my friends. Okay, then similarly, you go for other triangles COE. COE. why am I taking these? Because my friend, I am blind. OA. So I must have OA square. OB. Okay, my friend, I must have triangle OB as a hypotenuse. OC. I must have a triangle with OC as the hypotenuse. Now, if you can't read, my friends, then I'm sorry. Okay? That was the trick in that, and that's how it looks. Oh, so this is nothing great in that. Nothing great in that. The trick was in reading those carefully. So OA square, hypotenuse of one square triangle, plus hypotenuse of other triangle, plus hypotenuse of the third triangle. You change sides. Pure algebra. One pattern. Very simple sums, my friend, and worth 1 mark each. They come from mostly MCQs, but I said we will do it. A ladder 10 meter. Window is 8 meters. Find the distance. What is x? I have to find. Use Pythagoras, my friend. I cannot help you. A guy is attached to a vertical pole. This is 24 meters long. Has a stake attached to the other end. How far it should be? How far this should be? Okay, so that the wire will be taut. Okay, the height is 18 meters. Okay, so this is how I have to find my friend. See Pythagoras? 24 square is equal to 18 square plus x square. So 2 times Pythagoras, 1 mark each sum. They look nice to you, they look hard to you, I'm sorry for it. Again, looks difficult, but again sums are very simple. Pythagoras, plane. Aeroplane leaves an airport and flies north. Please learn east, west, north, south. East, west, north, south. Don't make your own directions in the exam. Okay? And speed is given. We must go for distance. Pythagoras uses distance, does not use speed. Okay? Now he says, aeroplane leaves an airport and flies north at the speed of 1000. This guy is flying at 1000 kilometers per hour. Another airport flies due west at a speed of 1200 kilometers per hour. How far they will be? What will be AP? So you convert it into distances and use Pythagoras. As simple as that. And right angle triangle AOB, you find the hypotenuse. Come here, my friends. This is basically application of trigonometry, but they made it into triangles, which is simple for us. So 2 poles are there and the distance is 12 meters. The pole will always be 12 meters. My friend, poles don't get bent, poles are straight. Okay, find the distance between their tops. Now we don't find like this. Top is here and here. So I will cut this off because till here their heights are same. So if this is 6 meters, this is 6. Yes, my friend, I have to only find this much. When I add, I will get the length. Okay, that's how we are working. So how do we find this? So you can see here, this is 12 and this is 6, 12, 6. So we have done by quadrilateral method. We have found. Then we use Pythagoras and we find out the 11 is 6 plus 5. I have 12 and I have x. X square is 5 square plus 12 square. Simple Pythagoras. So looks very nice, very good. 1 mark sum in the exam, mostly MCQ. Okay, so don't get very carried away. I'm doing a lot of hard work. No hard work. They're checking your fundamentals. Do you know your fundamentals or you don't know your fundamentals? Now look at a sum. How to get a 3 mark sum. Now my friends, again if I tell you, you again feel very angry. Rotate the diagram. First, learn to see one diagram. Second, learn to see another diagram. How many times I have to teach you this? Learn to rotate. Then only your life will become easy. And you'll be able to. Pythagoras, 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 Pythagoras. You see? I just write the sides. How many times, my friend, should I do? Okay. Learn to separate the triangles. They look quite similar. So now how do I use, which triangle should I use? Pythagoras. We will break your head now. First, I am getting AE. Okay, I am supposed to get AE. Where will I get AE, my friends? I need a right angle triangle. Don't talk foolish. So ECA. No other triangle can help me with AE as the hypotenuse. Okay? So I have used triangle EC. Then BD. I need BD as a hypotenuse, my friend. Only a fool will not be able to say that is the only triangle where this is possible. And that is the hypotenuse. If you can't identify hypotenuse, I cannot help you, my friends. Okay? Then you are seeing that when I add them together, I will get the answer. Then I also have DE. You see, my friend, DE. Now DE is here. BCE. That is how I will get my DE. And of course, I don't need, but if I want, I can also do for ABC. Okay. 4 right angle triangles are there, my friend. What should be difficult? I do not know. 1, 2, 3, 4. 4 Pythagoras plan. And if you can't add, then how to do geometry, I do not know. Okay, you have to just add. What to add? This is written here what to add. They didn't tell you add this with this. You can read. Where is AE? Where is BD? Okay? So be little smart, my friend. Don't give up. Don't get so hyped. Oh, so nothing is difficult. They give you all the clues in the sum. I'm sorry to say your sums are very simple. Okay? And you make it difficult because you got an attitude that no, prejudice. I'm very difficult. Nothing difficult. Here, perpendicular bisect PD such that DB, this is x, this is 3x. They've given this. Now, I have to prove AB square is equal to 2AC square plus 2BC square. Very nice. Which triangle should I take? Okay. Now, remember my friends, triangle I have to take, and I can see D and D common, and I see B and C. I hope you can see. Okay, so I will learn which triangles to take. So and because I need a A, I have ADB, ADC. This solves my problem. DC and AB with A common. Rule number 1. And of course, I have a big triangle that I cannot deny ABC. I can't do it. So it also is there. If you did not know how to identify this, I would be extremely sorry to help you. 2 times Pythagoras, I need to subtract the equation so that I could get the answer. Okay? And in these type of sum, I always advise people to first look from the bottom, never look from the top. How to learn the sum, how to do, always go like this. Don't go like this. You hurry, this way. Acha, then like because you are never used to. When this is added, I should have subtract. You tell me. In no method of adding, you will get these numbers together. So the logic is sometimes you have to minus and change the sign. That can only come when you are exposed to it. There is no shame at reading the sum, understanding it, and then solving. Because you are doing it the first time. Of course, I don't suggest to open the book and then do the sum for a homework or test. For practice, always look at the sum. Tricks are always there. BD is equal to 1/3 BC. Okay, so if this is 1 and this is 3. So I have to do 9 AD square is equal to 7 AB square. From where the error am I going to get? No problems. I will get, this is a equilateral triangle. All sides are A or X, whatever you like. So as you can see here, okay, BD is A upon 3, 1/3. This is A, this is A upon 3. Okay, my friends. Now DE is BE minus BD. D is betweenness. So A by 2, this is half, minus A by 3 will give me this. So this is A by 6. See that? And I will now take triangle ADE. DE and use Pythagoras. I know, my friends, already from here my DE is A by 6. Okay, and my AE by equilateral triangle root 3 upon 2 into sine. Remember 30, 60, 90 theorem. For equilateral triangle, now only I can get. If I don't know this, I should commit suicide. So first you must find DE. Second, find the answer for altitude, or which is also the median of equilateral triangle. And then your life will become easy. Otherwise, if you don't know your 8th standard, sorry. Who told you come to 10th? Go back, learn, come. Equilateral triangles in basic forms were done with you. Still difficulty, please contact us. Okay? Register, contact, we will help you with it. We'll give you similar sum. What has come in the past exam? Again equilateral triangle. 3 times square of one side. 3 times square of one side is equal to 4 times square of the altitude, height. This is what we have to do. My friends, side is A, 3A square, 4, height I just told you there, root 3 upon 2A, okay, I just told you there, and square. We have to prove this. Okay, so no problems. First, this is A by 2. A by 2. This is A, this is A. Okay, and this is root 3 by 2A. Your Pythagoras. Even God might help you. One step. Oh, it's difficult. Start 8th standard. Learn to solve. A ka A square, 2 ka 4. This is 1. So 4A square minus A square, 3A square, bottom will be 4. Learn to take LCM. I'll explain to you. If you can't take LCM, make it like this. Okay? And then only you will get that answer. Okay? So please practice. The tricks are all put on the board for you so that you don't have to get answered at all. Now, MCQ. Take AB is 6 over 3, AC is 12, BC is 6. Okay? Now, angle B. Is it a right angle triangle or not? Use Pythagoras, my friend. How many times I have to help you? If AC square is equal to BC square plus AB square, it is a Pythagoras, it is a right angle. Otherwise, it is not a right angle. So, basic thing they are checked. After so many sum, again they came back to check whether you know Pythagoras or not. Let us look at 6.6. Now comes your 10th standard sums. Now let us see how much confidence you have. Now you are asking me every time I am saying 8 lines, now come to 10th standard. Welcome. PS is the bisector of angle QPR. So this and this is equal. Prove that QS upon SR is equal to PQ upon PR. Okay, this is also called angle bisector theorem. Now, if you had studied angle bisector theorem, you would be able to do the same proof, and I did not use these words, but some is same. Now, construction. Construct this such that QP is equal to PT, number 1. Okay, and using the 2 parallel line and transversal. Friends, look at it before you make a mess. Okay? And then your life will become easy. So you will prove that PS is parallel to RT. You will prove this is parallel to this. Why? Friends. Okay? I'll again help you. 4 is equal to 3. 2 is equal to 4 because isosceles by construction. Therefore, 2 is equal to 3. Okay? That is how. So the trick was extremely simple. If the sides are equal, angles are equal. If If the sides are equal, angles are equal. Okay? That was the trick, my friend. Otherwise, keep struggling and learn alternate angles. Or you can even use the converse of basic proportionality theorem. I'll show you that also. Extremely simple. So if I have like this and I have 1 upon 2 is equal to 3 upon 4, then L is parallel to M. Converse, ulta. So your choice, right? How you wish to do. Extremely simple. You can do by similar triangle, you can do by basic proportionality, but basically this is angle bisector. Okay. You should learn the theorem also. In this, my friends, I have to prove dm square is equal to dn into mc, and dn square is equal to this. Millions of times I have told you, wherever is square, dm square is dm into dm, learn to separate. First, separate. Then second, make the ratio. Third, which triangle sides they are. Then prove them similar. That is how we work, my friends. Okay? So now, we have already done, but I'll help you once again. dm into dm is dn into mc. Okay, my friends? So, dm upon dn is mc upon dn. Sides in proportion. Now, my friends, I have sides dm, dn, like that. I will use the corresponding sides. So, I can take the triangle. Please have a look. Where are these sides? dm, dn, okay, dn, and MC. That's what MC. So you see, I have these triangles. That's how I get the triangles. So if you reach here, life is simple. Otherwise, you keep memorizing everything. Okay? That's simple. And in the second part, again, we have the same thing. We have same nonsense there. I have explained in the diagram which triangles I am taking and how am I doing. Now here I could not show you how to prove. So what I did is, you can see, I made O there. When I make O there, my life becomes simple in the terms of triangle. I can show like this, I can show like this. And here that was not possible. Here you would have only showed this and this. Okay, it would not give rise to. So this was a trick in that. Okay, by construction, you create a let the diagonals intersect at O. Then life becomes easy, my friends. Okay? And this method I have already taught you. Learn this method, then only it will work. Otherwise, sorry. Don't look at squares and get scared. No, squares can't help you. Squares only two types. Either in Pythagoras, it is the right angle triangle, or ratio of the side, which should have a common side. Here, angle ABC is obtuse, given, and I have made this perpendicular. I have to prove AC square is AB square plus BC square plus 2 times BC into BC. Okay, my friends? This is also the side bisector theorem. But how it is proved? First, we will take the big triangle. Big triangle is right angle triangle. ADC. Right angle at D. First, take the then, when I get DC, I will split DC into DB and BC. So, DB plus BC. This is what I will do, my friends. Okay? And when I square this, I will get A square plus B square plus 2AB. For blind people, A square plus B square plus 2AB. That is how the trick was there in the sum. I need factors which, when I square the sum, I will get my formula. Otherwise, it was difficult. So, this is the trick they have used. Of course, two signs are same. So, they are just substituting the B, nothing else. So, A square plus B square plus 2AB. The trick should have shown to you that basically I'm doing a quadratic expansion. Here again same story is given, but here an acute angle is given. That was obtuse, nothing great. Here you will get a minus simply because the angle is inside, nothing else changes. Now this is a square minus b square. Okay, so I have a minus b square is a square plus b square minus 2ab. What did you understand? When I see minus, I must know this is minus. That means I have to minus sine squares. Then only I will get the answer. Otherwise not possible. So when changing the side, I should get a minus sign. Nothing else. Not add, subtract. So it will become easy for you. Okay. Now DC is BC minus BD. Like that you will use the trick. Nothing else. You need a minus sign. Here all are combined. Plus and minus. I have written the solution. Kindly go through it. Both the sums have been combined in this. Nothing great. See the diagram? You can see instead of D, M is the right angle. And one more there from the previous sum, AB, median is also used. So this sum plus minus. And why D is a midpoint? It will become half. That is the 2. The half comes from the midpoint. Please practice. You want me to see 10 standard sums? Now have a look at 10 standard sums, which are worth 3, 4 and 5 marks. 5 mark sum. Prove that the sum of the squares of the diagonal parallelogram is equal to the sum of the squares of its side. Okay. Please have a look at my diagram. Construction we have to do. I have done construction. I have constructed. Okay, dotted lines. Please do construction first. Then take triangles B and D. First take B and D. My left side is a big triangle. Okay, my friends? Okay. Then when you have a look further on, my friends, I will use A and C. Sorry to say, my C looks disappeared. So I will use, in my second triangle, A and C. Right. Okay, my friends. And third, you are seeing when I began, I have used A and D. I have used A here. I have used A and D. And I have used B and C, which are written B and C. Learn which triangles to take, my friend. Then your life will become simple. Okay? Why did I select these sums? Because, my friend, square of the diagonal. Now, diagonal is, you can see, going here. Okay? And square of the sides. So, side is this piece, and this piece. I will add it square of the sides. Others are simple, my friends. Okay? Those sides are parallelograms, so you don't have to worry. That is easy. Okay? This side is only give me trouble. Okay, so when I made a square, this became automatically equal to this. If my construction was not done, I would have never been able to solve this. The trick was, that's why, to make it look like a rectangle, so life will become easy. This was the trick. And finally, I use my triangle as I told you, A and C, and get my answer. Okay? So, use the triangles very justifiably. You have to use A and D. One triangle, I will write the numbers. Two triangles, three triangles, to take. Because the sides belong to these. 4 times Pythagoras. Here, you are bringing in circles now, in triangles. They are interlinked. So you can't say which chapter marks are coming, weightage. Don't be foolish. Two chords intersected to prove that triangle APC is similar. So nice. Radius equal to radius. radius, vertically opposite. I will not help you more than this, my friends. Okay? So only foolish people. Of course, I can also go for alternate angles, but I don't need. Okay. Here, two chords intersect in point P. Prove that triangle PAC and PDB are similar. Now, my friends, as I tell you, you are again questioning the same thing. Okay, but we will still have a look for you. Okay, this is a cyclic quadrilateral. 1, 2, 3, 4 vertices are on the circle. Therefore, angle PAC is equal to PDB. Okay, property of cyclical triangles. If you don't know this, God only can help. Similarly, PCA is equal to PBD. Learn these properties. Then only you can do this. Otherwise, you can. This depends on cyclic, I would align cyclic quadrilaterals. Okay. Now, because you did step 1, you can do step 2. Otherwise, you will never be able to do step 2. Step 2 just says corresponding sides and proportion. So, such a great, that is by 2 marks. Okay? Learn the property of cyclic quadrilateral. The exterior angle is equal to the remote interior. Okay? Cyclical quadrilateral property. Have a look at sum number 7, my friends. Same. Again, I don't want to help you. Alternate, angles and this. Also, I must tell you one thing. Angles in the same segment are congruent. Okay. So CAP is equal to PDP. Don't forget. That was the trick in that. If they are similar, of course I know. The second part is just useless. If you cannot do the again same diagram as some methods. Okay, I cannot help you again. So this is also we have done before, and I tell you, memorize same sum is there again. Construct, let AC is equal to, let AB equal to AE or AE equal to this. These are isosceles, these angles are congruent. Again, I told you which angles, my friend. Two parallel lines and transversal theorem, same sum we are repeating, same sum. Okay, see. Converse of BPT, number 1, as I told you can use corresponding angles, alternate interior angles. That is the trick in this. Now word problem they made. Nazima is fishing. Okay. Now, what will be the horizontal distance? We are supposed to find horizontal distance of the fly from her. We have to find after 12 seconds. She's sitting and catching a fish. Okay? And they've given us various measurements. This is. Okay. And we're supposed to work it out. Now, my friends, okay, first, the length of the string, like hypotenuse, you can see, my friends, is, as you can see, 1.8 square and 2.4 square. Look at triangle number 1. Right hand angle. Pythagoras theorem. Okay, so this will give you 3 numbers. Answer. Okay, and she pulls the string at the rate of 5 centimeter and after 12 seconds. In 1 second 5, in 12 seconds how much? Okay, so the remaining string which will remain is 2.4 meter. This is what I find. And I have 2.4, I have 1.8. And I am supposed to find the horizontal distance of the fly, which will be this, you see 1.2 and instead of the horizontal come close, 1.5. This will come here, and she will pull, it will come here. So 2 times, you see, I have been looking at Pythagoras. Pythagoras. First, when I threw the thread. Second, when the thing came close, what is this? Okay, and taut means it's a triangle. You don't have curved lines, etc. So 2 times Pythagoras I'm supposed to use. my friends, this was triangles. Please practice. Get back to us if you have difficulties. Okay, register, subscribe.